We are well familiar with corrosion. Everybody here that drives an old vehicle has corrosion on their vehicle. Okay? And it's both at an industry level and at an individual level. We see corrosion in the oil patch, in the wells that are being drilled. Okay, we see corrosion in the agriculture industry with the chemicals that we have to store and the equipment that displaces that chemical. Corrosion is a spontaneous reaction, which means what? Oxidizing agent is higher than the reducing agent. Okay? These reactions occur generally against air or water. The biggest one that we're familiar with is with water and iron, which gives us rust. Okay? Many metals are strong reducing agents. When we look here on our data table, what do we see at the bottom down here? Do we see ions or metals? Metals. What do we see up here? Ions. Oxidizing agents are typically ions. Reducing agents are typically metals. Okay? That's a gas. Okay. Metals are strong reducing agents and will spontaneously react with oxygen and water. So illustrate rusting corrosion of iron in terms of electrochemistry. As electrons leave the anode, the iron will break down and rust. So, what's present? When we read this statement, we know that we're going to have iron, we're going to have water, and we're going to have oxygen. That's what it said. Many metals are strong reducing agents, will react with oxygen and water. It also says that these are strong oxidizing agents, and this is a strong reducing agent. So when I look at this piece of information, what is my oxidation half reaction? Yeah. So then my reduction half potential, or my half reaction, sorry, is going to be what? Okay, so I've identified my two half reactions. What's my next step? Balance the electrons. And how do I do that? Multiply iron by 4 by 2. So I'm going to get 4 irons Oh, gotcha. So what we see here is that the iron solid, right here, iron solid, is going to break down into iron ions, and we call this rusting. Okay? If I wanted to create an actual compound reaction, I could call this FeOH2, and there would be two of them. This is essentially the net ionic reaction. And we know that iron oxide, this one's iron hydroxide, but it has oxygen in it, creates rust. So one way that we get around that is we apply a protective coating. So something as paint or enamel or a plastic coating, and it prevents air and water from actually reaching the surface of the metal, and it stops the corrosion from actually taking place. Now, what happens when you're a farm kid and you live on a gravel road? What happens to your vehicle? Rocks chip away at that paint. You don't even need to be a farm kid. You drive down the highway and rocks ping off your vehicle, ping off your roof, ping off your mirrors. Okay? Sometimes you don't even have to drive that vehicle. Why do you think they put a film on the vehicles when they transport them from dealership to dealership? It's to stop that rock from damaging the paint, from creating a chink in the armor. Because the minute that it's not one solid surface, oxygen and water can now get in there. And it takes a while, but once it starts, it's very hard to stop. You can buy paint pens. Did you know that for your vehicles? Yep, I had for my very first vehicle that I had, it was a purple car, and I had a paint pen, and every time I got a rock in my vehicle, I went over it with my paint pen. No, that's called Auto Body Shop Rally for $975. Yeah, it's close. He's 3/4 of the way there. Oh no. Okay, another way that we can do it is we can do what's called the cathode protection way. And so what happens is you're going to give it a more reactive metal to go after. So the more reactive metal will react first, and it will stop the reaction with the metal you're trying to protect. And we call it a sacrificial anode. I don't know in vehicles if there's a sacrificial anode, but I know in like hot water tanks, there's a sacrificial anode. In heaters, in like holiday trailers, there's a sacrificial anode. Ask your parents if you've got holiday trailers or hot water tanks in your house. Ask them. Cisterns? Do they don't have electricity to them, do they? I'm like, they just hold water. And they're usually a plastic. They're a plastic container as opposed to a metal container. Yeah. Or they're trying to think of the cistern on the farm. They don't have one. They have a well. They have a dugout. You which? The deal is Culverts. Culverts are made out of galvanized steel because water flows through them regularly, right? Otherwise, you wouldn't need a culvert. Okay, so unlike a protective coating, the metal in a cathodic protection does not need to cover the entire surface. It just needs to be replaced. So that's it. That's corrosion in a nutshell. 2 ways to protect it. One is to cover it completely with a paint or an enamel or some kind of coating, or to use a sacrificial anode. So when we look at an anode, what is the half reaction at an anode? On an anode, what is the half reaction? Is it an oxidation half reaction at the anode or a reduction half reaction at the anode? Are we saying that with confidence?
Yes.
Okay, so if it's an oxidation half reaction, what is the agent? A reducing agent. So what would happen is if you had, say, we're making something out of aluminum, and we know aluminum's going to react. So what we would do, or here's iron. Here's a good example. Here's iron. If I wasn't going to coat it with an enamel, like a Rust-Oleum, you see those spray cans when they're fixing old vehicles, I would add a different metal. I would add a piece of metal that's zinc or a piece of metal that's aluminum to whatever it is that I have, and the reaction is going to happen there first. Now, on an industrial level, it might make more economical sense to have a plate of aluminum to painting an entire facility. So it comes down to cost effectiveness. Okay?